welcome the next speaker, who is Ole Lensmar and
Hello.
comes from Ole. Yeah,
Ole.
hello.
Hello.
Ole, sorry.
That's
I'm
okay.
going into Swedish mode here.
Okay. Ole then.
Yeah, Ole. Okay, so the question for you is that you are going to tell about OpenAPI and configuring your API gateway, and you have your slides here. That's the cool thing.
Yep.
And you seem to be all kinds of ready to talk.
I'm all set.
So take
okay.
it away.
Thank you so much. Thanks for the intro, and thanks to Kim for a super interesting session before that. Hello, everyone. I'm Ole Lensmar, the CTO at Kubeshop. I've been in the API world for almost 20 plus years. I was the chairman of the OpenAPI initiative, so I'm very kind of into the weeds of OpenAPI and all that. And here I'm going to talk to you about some new aspects of OpenAPI and API gateways and stuff like that. So jumping straight in, I think just to give a little of a background for the presentation, we see a lot of organizations and teams today adopting an approach where they're using OpenAPI or Swagger, as you might know it, to drive their API lifecycle. Basically meaning that you design your OpenAPI definition using some tooling, and then you use that OpenAPI definition to generate mocks or generate server stubs and write tests and virtualize and create documentation and do a bunch of things. And that OpenAPI definition kind of becomes the source of truth, right, for the API lifecycle or the lifecycle of your API. And on the other hand, we have a lot of, if you're publishing your APIs, obviously you're going to need some kind of API gateway that makes your API gateway available to your end users. And just as a recap there, I'm sure most of you know this, that the gateway is basically what kind of makes your API available in the sense that it provides routing and mapping capabilities. It can provide some quality of service functionality around rate limiting and timeouts, authentication, cores. And then if you go into more advanced features around orchestration and aggregation and transformation, and there's a lot of things gateways can do if you look at the different tools out there. And one thing that has struck me over as I've seen both the gateway world and the OpenAPI world evolve is that there's an obvious overlap here. Your OpenAPI definition contains a bunch of metadata that the gateway in itself, uses to do its thing, right? So there's operations and paths and methods and things. There's a message format and there's security schemes defined in your OpenAPI definition. And then you can even use OpenAPI extensions to kind of provide additional metadata for your APIs. There's a standard SLA for OAS for defining SLAs, and there's a lot of different approaches to kind of defining more operational aspects of using extensions. So that's definitely an overlap, with what you would say today that a gateway does. So it kind of felt obvious to us at Kubeshop when we got this project started is that wouldn't it be kind of obvious and great if you could just use your OpenAPI definition to configure your API gateway instead of using some native approach that's specific to that gateway that you're using. So why would you want to do that? First of all, well, one is that you have one source of truth, right? Your OpenAPI definition defines both functional and operational aspects of your API, which would make it easier for you to collaborate. If you have a team where you have ops and dev and test and architects and business analysts or working together, you can really huddle around that OpenAPI definition and put everything in there instead of having these things spread out in different documents or different configuration files or systems, etc. So both having that single source of truth both gathers it in one place, but also makes it easier to collaborate, especially if then you're using something like Git for, version management and workflows and stuff like that. And that in turn makes the kind of turns this into a very automation-friendly foundation for building your APIs, because you can automate a lot coming from that single source of truth, right? So you could configure, especially if it comes to gateways, you could automatically configure infrastructure, you can monitor, security, you could configure rate limiting and timeouts and other things that you would be specifying as metadata in your OpenAPI definition, instead of having to do that, in the UI or the configuration of the gateway that you happen to be using right now. And going back to this picture, basically, this would be focusing on the deployment runtime of the lifecycle, right? When it comes to the gateway. But as I said before, the definition would still be driving, or could still be driving, many of the other phases in the lifecycle. So if you look today, there are already a couple of approaches to using OpenAPI Swagger to configure your gateways. One is you can import your OpenAPI definition into the gateway's management console and or UI, and that gateway will then be able to do some things with it. We'll get back to that. One is to generate the actual configuration for your gateway using your OpenAPI definition. And then using that to configure the gateway, obviously. And the third would be to actually have a gateway that's natively using OpenAPI as its configuration format. And in all of these, you'll probably want to use some extensions, OpenAPI extensions to the OpenAPI definition to define more operational aspects of the API, since the OpenAPI itself, or Swagger, is more focused on functional aspects of the API and not as much quality of service. But that's the great thing about OpenAPI, is that you can easily add your own extensions, to whatever business needs you might have. So just looking at the first approach here, importing an OpenAPI and definition to configure your gateway. This is the easiest way to do it, and it's also very common. If you look at everything from AWS to Azure, Google, Glue, and many, many more, they usually have a feature where you can import your OpenAPI definition, and from there they'll configure paths and other things that they can extract from that definition for you. The next step is then that you'd have to manually, using their corresponding management interfaces, add additional configuration metadata, around, rate limiting or timeouts or security or whatever else. And this is a great way to get started, but it's not always great for if you want to have an iterative workflow. What I mean there is, let's say you import your initial OpenAPI definition, you configure it with all the stuff, and then you make some changes to the OpenAPI definition. You want to re-import. Maybe you've changed some paths. Maybe you've changed the parameters, the schema, some security aspects. It's not, many of these tools won't be able to really update from based on. Those things you'll have to do manually. So putting a more automated workflow into place in this context is hard. And of course, the definition itself is not the source of truth for everything related to your API. Second approach, as I mentioned, is generating your gateway configuration. So you have some tool like Swagger Code-Gen or OpenAPI Generator, and I'm sure there are others out there, that takes your definition and generates the configuration for your gateway. And this is good in the sense that it would allow you to automate that generation as part of your workflows, and it plays nicely with GitOps, which is all the rage, or a great thing in the Kubernetes world. You'd still need extensions, of course, to define any functionality that's specific for the gateway, and of course you'd have to make sure that generation of that configuration is done automatically as part of your build or CI/CD, and also then applied to your gateway. So the gateway would have to support a kind of dynamic reconfiguration based on as you evolve the API. And then finally, you could have a gateway that actually uses OpenAPI natively, right? So instead of having an intermediate configuration format, the gateway could just use the OpenAPI definition with extensions to configure itself. And that, once again, works nicely with automated and iterative workflows. You don't have the intermediate steps of having to generate files and apply them. You'd still need the extensions. And when objection you could have here, and also to the previous point, is should everything really be in an OpenAPI definition, right? Should you be configuring very operational aspects like scaling or high availability or whatever else? Should that really be defined in in that single YAML file? That YAML file is going to grow, and it's going to contain a lot of stuff that you might not want. And we'll talk a little bit more about this further down the line. Just switching over to Kubernetes a little bit, because it's one of the main things happening today. If you're publishing, if you're deploying your APIs under Kubernetes and you want to make that API available to the outside world, or depending on your topology and infrastructure, you need to use something called an ingress to expose that API. And ingress is a resource definition, and then there are a bunch of ingress controllers which implement the ingress standard, and then which allow you to expose your API. And there's a bunch of these. Nginx ingress is maybe the most common one. Ambassador, Traffic, Linkerd, Istio. There's service meshes, as we heard in the previous talk, also kind of venture into this area. And usually, if you look at API gateways today, the well-known ones, popular ones like Kong, for example, they also have ingress controllers wrapped into them. So they kind of double. Their heritage is predates Kubernetes, but they've now kind of adapted to the Kubernetes world by also providing ingress controllers. And there are some challenges specific to ingress, and one is that the ingress standard itself is pretty underwhelming, in the sense if you really want to have very advanced configurations, or you need to configure many aspects of your API. And there's a new standard coming up called the Gateway API, which is meant to replace it. Other is that, as I mentioned, each ingress controller, there's a bunch of different ones, and they all work differently, right? So they kind of piggyback off that very slim initial ingress standard, but then they have their own approach to configuring all the other aspects of APIs. So that would be, either they have one big YAML file, or they're added as annotations to your existing ingress controller, or there's a mixture of those. So it's really, really hard to move from one ingress controller to another, just because they're so different in how they're configured, and of course the feature set that they support. Also, just in the nature of Kubernetes, everything is CRD and configuration driven. So usually you don't configure things through a UI, or if you do, that UI will eventually generate a YAML file that you apply to your cluster, which is maybe a little bit of a different approach than what you might be used to outside of Kubernetes. And another more workflow related challenge is that people managing ingress controllers or gateways in Kubernetes are usually ops people, or the ops team, but the people building APIs are usually on the dev side, and they can, depending on the culture or the way you work, there could be a workflow contention, right? As a developer, I've added new things to my API. I need to configure my ingress controller, but the ops person is not available right now, and they're the only one that can do it. So you get a kind of a contention around being able to iterate and evolve quickly. So taking a step back into looking at everything I've already talked about, wouldn't it be great if you could use then OpenAPI to configure your ingress controller, just like we've talked about now? You'd have one source of truth, right? Your OpenAPI definition. You wouldn't have to learn any new or YAML, configuration files, and that's usually a good thing. And you could easily automate your workflows. You wouldn't be affected by these contentions that I mentioned. And this is why we built a project we call Kusk, which is a Swedish word for coachman. And Kusk is basically a project to help you automatically configure your gateway based from your OpenAPI definition. It makes your OpenAPI definition the source of truth for all the functional aspects as it is today already, but also more quality of service or operational aspects, related to routing, to rate limiting, cores, which is a pain, as you might know, timeouts. But also, thanks to the metadata we have in OpenAPI, we can do a bunch of things out of the box, right? Like validation and mocking and coverage calculation and other security, a bunch of things that we could kind of, thanks to all the metadata we have, we can automatically provide that functionality. Kusk is 100% open source. You can find it on GitHub. There's no commercial offering. Sorry, if you're into that kind of thing, just go check it out there. And Kusk you can use in two ways. You can use it with your existing ingress controller. So if you're already into Nginx, Ingress, or Ambassador, or one of the others, Kusk will be able to generate configurations for you. Or you can use what we call Kusk Gateway, which is a standalone Ingress controller, which is totally OpenAPI driven. So you don't need to learn any other formats. You just use your existing OpenAPI definition and add extensions to it to configure your gateway. I just need to check time. Okay. So, and the way it does this, and as I've alluded to and before, and as other gateways do it too, is that we have an Xcusk extension that you would add to your OpenAPI definition, which allows you to specify things like rate limits, timeouts, cores. You can disable specific paths or operations. You can enable or disable validation and mocking. And of course, there are also some configuration options which are more related to the cluster configuration or the operational aspect. So you can see here to the right, this is just an excerpt from the legendary pet store OpenAPI definition. So at the root level here, we have a Kusk extension, which provides some cores settings, also some path rewriting, and also which service, Kubernetes service, this should be going to. And we can also see that we've disabled here the put operation on the pet path. So this is a way of easily, if you have operations, for example, that you don't want exposed to the outside, the administrative, or they're not finished or whatever, you can use that functionality. But also, as you can see here, other things related to the more functional, operational aspects of your API. And the example doesn't contain rate limits or timeouts, but you can do all that as well. So why would you want to use this? Well, as I mentioned before, configuring and changing Ingress controllers is tedious, right? You'd have to learn a lot of different files. The way they implement many of these features is not consistent. So just because you've learned how to configure cores for Nginx Ingress doesn't mean you know how to configure it for Ambassador, because they do it totally differently. And Kusk-Gen, which generates these configuration files, does that kind of transparently. You have your OpenAPI definition with your extensions, and then you tell it to generate for this or that controller, and it'll generate all the correct configuration files. So you can keep all your API metadata in one place, and you'd have a consistent approach. Would also could make it easy for you to try out another Ingress controller. Maybe you're not happy with the performance of the one you're using, or with some of the features that it has or doesn't have. And using Kusk, you can easily say, okay, let's just generate for a different one and redeploy, and you're all up and running, instead of having to kind of figure out how do I map these YAML files to those YAML files. And if you're into the GitOps kind of thing, what this kind of shows you is that as a developer, you would be putting your OpenAPI definition in Git. A tool like Argo CD or Flux would be able to then, as part of the reconciliation or the deployment, continuous deployment workflows, reading that definition, running Kusk to generate the Kubernetes manifests for your target gateway. So these Nginx Ingress Ambassador Linkerd. And then Argo CD would kind of see if any updates have been made and apply those to your cluster automatically. So you could have a super automated workflow where your developers are continuously evolving your API definition, adding things, removing things, configuring things. And a tool like Argo CD could always make sure that the configuration of the gateway in your cluster is up to date. So there's no one's involved in kind of manually having to keep all these things in sync. Super cool. Okay, talk a lot, sorry. And finally, wouldn't it be great, even greater, if your gateway could speak OpenAPI natively, right? So you still have one source of truth. You would have new YAML files, and you could automate your workflows, but you could also use OpenAPI to drive a bunch of functionality. So you wouldn't have to write code for validating or for creating nice error messages. You wouldn't have to use another mocking framework, or you wouldn't have to, a bunch of things that we can kind of extract from the OpenAPI definition to provide functionality to make your life as a developer easier. And this is why we built something called Kusk Gateway, which is the extension of Kusk-Gen, similarly to Kusk-Gen. Your OpenAPI definition becomes a source of truth. You can rapidly iterate, but as an additional benefit, you get all these features that we can extrapolate from your OpenAPI definition in your schema. Kusk Gateway in itself is also open source 100%, as anything in the Kusk ecosystem. It's built on Envoy, which is a very battle-proven proxy, a networking proxy, and which is also used by other API gateways in the space. So we're not reinventing kind of the network layer part of this. This is more of a control plane. We're using the same extensions as Kusk-Gen. So if you've started with one, you can easily transition to the other. This is deployed as a standard Kubernetes controller operator, and it enables, at this point, request validation and mocking, so you can super easily just turn on validation. The great thing with validation is it's one of those things that server-side developers or API implementers, as myself, hardly spend a lot of time on. We return a 400 something error if there's invalid input, but as a user, you'd probably want to know a little bit more about what did you send, what was wrong with your request, and Kusk Gateway can automatically provide really nice error messages, which takes time both of the server developer and for the client, because it'll be easy for them to figure out what they're doing wrong. And mocking is something that we also do just based off the OpenAPI definition. So you can easily just turn on and off mocking for different operations. Let's say you're still in the design phase, you haven't actually implemented all operations, you want some of those to be mocked out for the clients to be able to have something to work with. You can also do that. Once again, we can pull all that metadata from the OpenAPI definition. You don't have to configure any additional plugins or anything like that. And Kusk Gateway has a UI where you can obviously see what APIs are deployed. You can use an embedded Swagger UI to just try out your API, and we're adding a bunch of features around looking through transaction logs and metrics and health analytics and all that kind of stuff. And finally, how would Kusk Gateway tie into your workflow? Well, I think similar to some before, your devs would be, having your Git repository where you both have the code and your OpenAPI definition. Using some kind of CI/CD process, you could deploy your APIs and configure Kusk Gateway automatically, which then in turn uses Envoy, to proxy and validate and transform or whatever else it does, the traffic coming from consumers going to your services. So you can definitely have a very automated workflow with Kusk Gateway, and it really takes the goal here is to make it really easy for API developers moving into Kubernetes to quickly deploy their APIs and make sure they're available. And just revisiting this picture, right? So Kusk would kind of tie into these different phases of the life cycle, and as we add more features, we can add more. But it's still the core idea here is use OpenAPI as your single source of truth. Use a design-first approach. Let that API definition drive all these phases in your life cycle. If you're using Kusk, that's great. If you're using some other tool, that's great too, because I think there's a lot of benefit in that approach, especially as you scale your teams and your APIs. And I think I've said the word OpenAPI more than ever in that short time. So thank you so much for listening. Happy to answer any questions here. I'll also be in the booth. We have a virtual booth if you want to dive in or have thoughts on this. I'd love to hear kind of how this aligns with how people are building and deploying APIs under Kubernetes today. So I'm all ears.
Great. We don't yet at least have any questions, and we are kind of running out of time, but I have to say I had this deja vu of being in an OpenAPI TSC meeting and having like a ton of information flowing over me. But I do think that this is an important problem that you guys are solving, because there's a lot of problems in having an API fine with OpenAPI, but then your gateway configuration and scripts and everything is a complete mess. And having dealt with a lot of gateway products with like having the mocking there and having the other gateway scripts there and everything. So if one can make that easier, it's wonderful. But question is that, do you see like, is there something that you have to absolutely put into your OpenAPI specs so that it will work well with this configuration, or does it matter?
So yes, you'll definitely have to tell the gateway to which service the traffic is to be routed. So I think that's the minimum that you'd have to configure. But apart from that, that's it. And then all the other things like rate limiting and cores and blah, 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 those are added benefits that you don't have to use. So you can just, you can get very simply, take your OpenAPI definition, add the extension that tells which service that hosts the API and deploy it, and you're up and running, versus having to create the YAML files, et cetera, et cetera, et cetera. So we definitely, this is about empowering developers and being efficient and productive when they're building iterative around their workflows. So that's kind of the goal. And
probably having examples, like proper examples in the OpenAPI helps if you want to also use the mocking features. And
definitely, so we can, let's not go down the mocking route, but you're totally right. And there's a lot to be said about that. But you're right, of course. the better your OpenAPI definition is in all aspects, the
Yes.
better the end user experience will be, right? The
Exactly.
DX or whatever you want to call it.
Great. I think that there's a lot to chew on with this talk, and we'll wait for the next one in the next
Thank you
event.
so much. Thanks.
Thank you. Bye.